The effect of noise on speech recognition. Noise is a fact of life. All audio recordings have some degree of noise in them, and unhandled noise can wreck the accuracy of speech recognition apps. To get a feel for how noise can affect speech recognition, download the jackhammer.wav file. As always, make sure you save this to your Interpreter Sessions working directory. This file has the phrase, "the stale smell of old beer lingers," spoken with a loud jackhammer in the background.
The stale smell of old beer lingers.
What happens when you try to transcribe this file? As you can see, it's way off. So how can you deal with this? One thing you can try is using the Adjust for Ambient Noise method of the Recognizer class. That got you a little closer to the actual phrase, but it still isn't perfect. And also, "the" is missing from the beginning of the phrase. Why is that? The Adjust for Ambient Noise method reads the first second of the file stream and calibrates the recognizer to the noise level of the audio. Hence, that portion of the stream is consumed before you call record to capture the data. You can adjust the time frame that Adjust for Ambient Noise uses for analysis with the duration keyword argument. This argument takes a numerical value in seconds and is set to 1 by default. Try lowering this to 0.5. It looks like that has allowed speech recognition to pass the entire spoken phrase for recognition, but now you're back to where you were before, with a transcription that's the same as if noise adjustment hadn't been used. Sometimes it just isn't possible to remove the effect of the noise, the signal is just too noisy to be dealt with effectively, and that's the case with this file. If you find yourself running up against these issues frequently, you may have to resort to some pre-processing of the audio. This can be done with audio editing software or a Python package, such as SciPy, that can apply filters to the files. A detailed discussion of this is beyond the scope of this course, but check out Alan Downey's Think DSP book if you're interested in it. For now, just be aware that ambient noise in an audio file can cause problems and must be addressed in order to maximize the accuracy of speech recognition. When working with noisy files, it can be helpful to see the actual API response. Most APIs return a JSON string containing many possible transcriptions. The Recognize Google method will always return the most likely transcription unless you force it to give you the full response. You can do this by setting the Show All keyword argument of the Recognize Google method to true. As you can see, Recognize Google returns a dictionary with the key alternative that points to a list of possible transcripts. The structure of this response may vary from API to API and is mainly useful for debugging. By now, you have a pretty good idea of the basics of the speech recognition package. You've seen how to create an audio file instance from an audio file, and how to use the record method to capture data from the file. You learned how to record segments of a file using the offset and duration keyword arguments of record, and you experienced the detrimental effect noise can have on transcription accuracy. Now for the fun part. In the next section, you'll see how to transition from transcribing static audio files to making your project interactive by accepting input from a microphone. Working with microphones. To access your microphone with speech recognition, you'll need to install the PyAudio package. Close the REPL you've been using, and let's take a look at the steps needed to install PyAudio. The process for installing PyAudio will vary depending on your operating system. On a Debian-based Linux like Ubuntu, you can install PyAudio with apt, as seen on screen. Once installed, you may still need to run pip install PyAudio, especially if you're working in a virtual environment. For macOS, first you'll need to install PortAudio using Homebrew, and then install PyAudio with pip. Installing on Windows can be a little involved as the standard pip install method doesn't work on Python 3.7 and above, and attempting an install will lead to a number of errors of missing components on your system. However, the unofficial Windows binary page offers wheels which can be downloaded and installed using a command seen on screen. As with the installation of any software, you need to ensure that you're happy that the software you're installing is legitimate, but these are packages I've personally used on a number of projects involving Windows where no other solution was available, and they've worked well. Once you've got Pi Audio installed, you can test the installation from the console. Make sure your default microphone is on and unmuted. If the installation worked, you should see something like this. Hello from RealPython. The microphone is working correctly. The microphone works. Go ahead and play around with it a little bit by speaking into your microphone and seeing how well speech recognition transcribes your speech. If you're on Ubuntu and get some funky output, ALSA lib unknown PCM, refer to the troubleshooting page of speech recognition's documentation for tips on suppressing these messages. This output comes from the ALSA package installed with Ubuntu, not speech recognition or Pi Audio. In all reality, these messages may indicate a problem with your ALSA configuration, but in my experience, they don't impact the functionality of your code. They're mostly a nuisance. The microphone class. Open up a new Python REPL and create an instance of the recognizer class. Now, instead of using an audio file as the source as seen previously, you'll use the default system microphone. You can access this by creating an instance of the microphone class. If your system has no default microphone, such as on a Raspberry Pi, or you want to use a microphone other than the default, you'll need to specify which one to use by supplying a device index. You can get a list of microphone names by calling the list microphone name static method of the microphone class. Note that your output may differ from what's seen on screen. The device index of the microphone is the index of its name in the list that's returned by list microphone names. Given the output you've seen on screen, if you wanted to use the Black Hole 2 channel microphone, which has index 2 in the list, you'd create a microphone instance using the code seen on screen now. For most projects though, you'll probably want to use the default system microphone. Using Listen to capture microphone input. Now that you've got a microphone instance ready to go, it's time to capture some input. Just like the audio file class, microphone is a context manager. You can capture input from the microphone using the Listen method of the recognizer class inside of the with block. This method takes an audio source as its first argument and records input from the source until silence is detected. Once you execute the with block, try saying hello into your microphone. Wait a moment for the interpreter prompt to display again. Once the prompt returns, you're ready to recognize the speech. If the prompt never returns, your microphone is most likely picking up too much ambient noise. You can interrupt the process with Ctrl-C to get your prompt back. To handle ambient noise, you'll need to use the Adjust for Ambient Noise method of the recognizer class, just like you did when trying to make sense of the noisy audio file. Since input from a microphone is far less predictable than an input from an audio file, it's a good idea to do this any time you listen for microphone input. After running this code, wait a second for Adjust for Ambient Noise to do its thing, and then try speaking hello into the microphone. Again, you'll have to wait a moment for the interpreter prompt to return before trying to recognize the speech. Recall that Adjust for Ambient Noise analyzes the audio source for 1 second. If this seems too long to you, feel free to adjust this with the duration keyword argument. The speech recognition documentation recommends using a duration of no less than 0.5 seconds. In some cases, you may find that durations longer than the default of 1 second generate better results. The minimum value you need depends on the microphone's ambient environment. Unfortunately, this information is typically unknown during development, and in my experience, the default duration of 1 second is adequate for most applications. Handling unrecognizable speech. Try typing the previous code example into the interpreter and making some unintelligible noises into the microphone. You should get a response similar to seen on screen. Audio that cannot be matched to text by the API raises an unknown value error exception. You should always wrap calls to the API with try and accept blocks to handle this exception. You may have to try harder than you expect to get the exception thrown. The API works very hard to transcribe any vocal sounds, and even short grunts were transcribed as words like how for me. Coughing, hand claps, and tongue clicks would consistently raise the exception. So far, you've seen how to recognize speech in English, but what if the speech you need to recognize isn't in English? You'll see how to deal with that situation in the next video. Recognizing speech in languages other than English. So far, in this course, we've been recognizing speech in English, which is the default language for each recognize method of the speech recognition package. However, it is absolutely possible to recognize speech in other languages, and it's quite simple to accomplish. To recognize speech in a different language, set the language keyword argument of the recognize method to a string corresponding to the desired language. Most of the methods accept a BCP47 language tag, such as ENUS for American English or FR for French. For example, what you'll see on screen next recognizes French speech in an audio file. Note that only the methods seen on screen accept a language keyword argument. To find out which language tags are supported by the API you are using, you'll need to consult the corresponding documentation. A list of language tags used by Recognize Google can be found in Google's online documentation. Now that you've gained skills and experience in speech recognition, it's time to put all that you've learned together in the final section of the course. Putting it all together, a guess the word game. Now that you've seen the basics of recognizing speech with the speech recognition package, let's put your newfound knowledge to use and write a small game that picks a random word from a list and gives the user 3 attempts to guess the word. The full script is included in the course files and is fairly long. The overall structure of the program involves a function that recognizes speech, recognize speech from Mike, and a main game loop which chooses a random word and allows the user to make guesses. Open your chosen code editor and create a file called guessing_game.py. Firstly, the necessary imports of random, time, and speech recognition are needed. The recognize speech from Mike function takes a recognizer and microphone instance as arguments and returns a dictionary with 3 keys. The first key, success, is a boolean that indicates whether or not the API request was successful. The second key, error, is either none or an error message indicating that the API is unavailable or the speech was unintelligible. Finally, the transcription key contains a transcription of the audio recorded by the microphone. The function first checks that the recognizer and microphone arguments are of the correct type, and it raises a type error if either is invalid. Next, the function uses the microphone input as a source, and firstly calls adjust for ambient noise to calibrate the recognizer to the changing noise conditions before every recording. The listen method is then used to record microphone input. The default values for the response dictionary are then set. These will be altered depending on the success, or otherwise, of the speech recognition. Next, Recognize Google is called to transcribe any speech in the recording. A try except block is used to catch the request error and unknown value error exceptions and handle them accordingly. The success of the API request, any error messages, and the transcribed speech are stored in the success, error, and transcription keys of the response dictionary, which is returned by the recognize speech from Mike function. You can test the recognize speech from Mike function by saving guessing_game.py and running the following in an interpreter session that started in the same location as that file. Hello. Now return back to your editor to complete the game code. The game itself is pretty simple. First, a list of words, a maximum number of allowed guesses, and a prompt limit are declared. Next, a recognizer and microphone instance is created, and random word is chosen from words. After printing some instructions and waiting for 3 seconds, a for loop is used to manage each user attempt at guessing the chosen word. The first thing inside the for loop is another for loop that prompts the user at most prompt limit times for a guess, attempting to recognize the input each time with the recognize speech from Mike function and storing the dictionary returned to the local variable guess. If the transcription key of guess is not none, then the user's speech was transcribed and the inner loop is terminated with break. If the speech was not transcribed and the success key is set to false, then an API error occurred and the loop is again terminated with break. Otherwise, the API request was successful, but the speech was unrecognizable. The user is warned and the for loop repeats, giving the user another chance at the current attempt. Once the inner for loop terminates, the guess dictionary is checked for errors. If any occurred, the error message is displayed and the outer for loop is terminated with break, which will end the program execution. If there weren't any errors, the transcription is compared to the randomly selected word. The lower method for string objects is used to ensure better matching of the guess to the chosen word. The API may return speech matched to the word apple with a lower or uppercase first letter, and either response should count as a correct answer. If the guess was correct, the user wins and the game is terminated. If the guess was incorrect and the user has any remaining attempts, the outer for loop repeats and a new guess is retrieved. Otherwise, the user loses the game. Next, you'll see a few runs through the game. Firstly, one where the user guesses correctly. Banana. Next, a run where the user guesses incorrectly 3 times and loses the game. Banana. Lemon. Apple. Finally, a run showing how the exception handling for unrecognized speech allows multiple attempts to record and recognize speech. Apple. Banana. Lemon. So now you've completed everything we're covering in the course, let's take time to review what you've learned. Summary. Well done, you've made it to the end of the course. In it, you've seen how to install the speech recognition package and use its recognizer class to easily recognize speech from both a file using record and microphone input using listen. You saw how to process segments of an audio file using the offset and duration keyword arguments of the record method. You've seen the effect noise can have on the accuracy of transcriptions and have learned how to adjust a recognizer instance's sensitivity to ambient noise with adjust for ambient noise. You've also learned which exceptions a recognizer instance may throw, request error for bad API requests, and unknown value error for unintelligible speech, and how to handle these with try-except blocks. Speech recognition is a deep subject, but the foundations you've learned in this course will allow you to investigate further the areas that you're interested in this exciting topic. As ever, we hope you found this course useful, and we'll see you again soon at realpython.com.